Hello friends, welcome to Granth. Today's problem is maximum width of a binary tree, and the problem statement says that given a binary tree, write a function to get maximum width of the given tree. The maximum width of a tree is the maximum width among all the levels that are present in the tree. The width of one level is defined as the length between the end node, the leftmost and the rightmost non-null node in the level, where the null nodes between the end node are also counted into the length calculation. So what it means is that whatever is the not null node on the right hand side of the tree and the not null node on the left hand side of the tree, we need to get the distance between those two, and we need to find for this tree what is the maximum width of that particular tree. And the point to note here is that we need to consider the null nodes as well. So for this particular tree, if we see, the width of this tree at level 1 is 1, the width of this tree at level 2 is 2, and the width of this tree at the last level is 4, because we have one node as 5, one node as 3, the left node of 2 is null, so that will be also counted, and the right node of 2 is 9. So the number of nodes at this level is 4, which is maximum for this tree. So the width of this tree will be counted as 4. Now if we consider this example, so for this example we go to this level. So at this level the width is 1, at this level the width is again 1 because there is nothing on the right hand side, and at this particular level the width is 2 because we don't have anything which is not null on the right hand side. The third example, in the third example at this level, so for this example the maximum width is 2. Now for this example, if you see, at this level the width is 1, at this level the width is 2, at this level the width is again 1 because there is nothing on the, there is no not null node on the right hand side. So the maximum width is 2, which comes from this level. And finally this example, if you see, so this example, the width at this level is 1, at this level it's 2, at this level it will be 5, and then the right side of 3 which is null and the left side of 2 which is null. So width at this level will be 4, and width at this 8th level will be this level will be 8 because this is one node, there will be a right node of 5, there will be two nodes which will be the right of this 3. So if 3 has a null node, then that null node will have another null node. Same thing goes for 2. So 4 null nodes here, one null node for the right side of 5 and one null node for the left of 9. So in all there will be 8 nodes at this level, which is the maximum. So we need to return 8 in this particular case. So let us solve the problem. I hope the problem statement was pretty clear to you. So in solving a problem like this, we don't need to worry about what is the value of each node. We are only concerned with the width. So what we are going to do is we'll assign some ID to each of the node. And how we'll assign this ID is, we'll say the first node that is present, the root node, will have a value as 1. Okay. The left of this node will have a value 2 times of the root node. So this will have a value 2, and the right of this will have value 3. So the left side has a value 2, which is 2 times this node. This is 2 times plus 1. Now if I have another level here, so if this is 2, then I can say that the next at the next level it can be 4, then 5, then 6, and then 7. So if we see here, and this node is again 2 times the value of the root node, and this one is 2 times plus 1. So what we can deduce from, and same thing goes for these two nodes also. So what we can deduce from here is that every child node, if it is on the left hand side, so left hand side will have a value 2 times the node, and for the right side it will be 2 times the node value plus 1. So this will be this is how we can assign an ID to each of these nodes. Now the distance between the leftmost node and the rightmost node will be equal to the right ID minus the left plus 1. So here the distance will be 3 minus 2 plus 1, which is equals to 2. So it means the width here is 2. In this particular scenario, the width will be equal to 7 minus 4. So which will be 7 minus 4, which is 3, plus 1, which is equals to 4. So it means that width at this level is equal to 4. Now suppose this 7 was missing from this node, so which brings us to a problem like this, where we had 9 here. In place of 9, the 9 will be on the left hand side of 2. So from here we can say that the maximum width of this is 6 minus 4, which is 2 plus 1, 3. So that is the maximum width. So let us solve this particular problem. So for this, what we need is, we need to maintain the leftmost element. We need to keep track of the leftmost element of that particular level. So we'll use a list here. So it will be a list of integer. I'll say L new array list, and we will do a DFS. Okay, so we'll do a DFS in this particular scenario, and whatever value that we get from the DFS, that will be the answer. So when we do a DFS, what we need to pass on is, we need to pass on the root value, we need to pass on what is the level, the current level. So the current level is 0. The next thing that we need to pass is what is the ID of this element, or the number that I have assigned. Like here I assigned it as 1, so I will say 1, and we'll pass this list that we have added here. So here when I say private in DFS, I need the tree node, which will be root. Then I will have the level, I will have the ID value, and I will have this list of integer, which is L. Okay, and I need to return the width from here. So the what will be the width, like I said here, so the width will be equal to the right minus left plus 1. So it means that I need to calculate the left hand side width and the right hand side width of this particular tree. So we'll first see that if the root that we have got is equals to null, so in this case we will return 0 from here. If the level that we are at, it means that if the level is equals to L dot size, it means that initially the list was null, so it means that I am at the level 0. So if I am at level 0 here, so I will add the first element in my list. So I will say L dot add. So this is to keep track of the leftmost element. So I will add this ID here. Now next time when I come, if the list dot size is now 1, so if when I come to the level 1, so whenever I come to the level 1 for the very first time, so that time I will add the leftmost element here into my list. So that way I will keep track of the leftmost element. Okay, and I can say that my current value, or the current value of the node here is, or the current width that I have here is equal to the leftmost node, or the which is equals to the left minus the right, or the ID that I am at currently minus the ID for that particular level. So L dot get for that level and plus 1. So if I am at this level, so I will say that ID is 1 minus, at this level the leftmost element is 1 plus 1, so the width here is 1. If I am at this level and I am at element 3 suppose, so ID is 3, the leftmost element for this level is 2, so it will be 3 minus 2 plus 1, and the width will be 2. And after that I need to go left. So when I go towards left, so I do this DFS, I will pass on the root. Now the next is level, so level will be whatever level I am at plus 1, and ID will be, since I am going towards left, so this will be root dot left. So if I am going towards left, so I said that whenever we go towards left, it will be 2 times the node value, or 2 times the ID that I am at currently, and this will be L, and int of right will be equal to DFS of root dot right level plus 1 level plus 1, and the id will be 2 times the id plus 1, and this will again be L. Okay, and finally when I return from here, so what I will return is the max width. So it will be math dot max of my current width, whatever current value that I have, or whatever max I got from my left hand side or the right hand side. It will be math dot max of left comma right. So this is what I will return. So let us submit this. I hope this is clear, the explanation was clear. Int cannot be converted to boolean. Oh god, every time I do all these silly mistakes, apologies for that. So yeah, this is accepted. Let us submit the solution. So this one is accepted. So I hope the explanation for this was pretty clear, and the only trick here is that we don't need to consider, or we don't need to think about what is the value of each of the leaf or the node value of the tree. We only are concerned with the IDs of each of the node of this particular tree, so that we can find the distance between the leftmost node and the rightmost node and keep track of the max, whatever max we are at currently. So that is how we will solve this particular problem. I hope the explanation was clear. Do let me know how you solved it, and thanks for watching the video. Do like, share and subscribe.